Viewers, and welcome back to the Self-Made Auto Channel. Got a 2008 Chrysler Sebring. It's got the big 2.4, the money lights on, and it's up to us to figure out what's going on. So we're going to be using the Y-Tech. Now I did have the Autel plugged into this just to pull codes, and I see it had Evap codes. And I'll tell you right now, if you own an Autel and you're working on a Chrysler, whether it's an NVLD system, an LDP, eSIM and ESIM, Evap system, any of the Chrysler Evaps, do not use the Autel. Autel has had a problem with Chrysler Evap data being correct for many, many years, and don't trust it. You will go down the road of it needs a PCM, and you'll be wrong. So either use something else. Snap-on works good on Chrysler Evap, and then in this case, we're going to like to use the OEM tool. So just be ye warned. We're going to go to all DTCs. We'll see we have this Evap small leak. We're only worried about the PCM codes. And then we have this problem with the intake manifold runner control stuck closed and intake manifold runner position sensor circuit high. Bank 1. I took a little look in on the engine. It looks like this thing's brand new. So let's devise a plan, get a circuit diagram, and then see if we can figure out what's up. So looking up here, here's our schematic. I have to be writing service data on this one, which is great. So this is the intake manifold, what they call it, a manifold flow valve, or valve manifold flow. It should be, I was going to say it should be 5 wires. So we have a standard, that's weird. I think that might be labeled wrong. Sensor ground and ground. Oh, no, it's not. Okay, so we have our sensor ground, our 5-volt supply, and then our signal. So a standard 3-wire potentiometer. And then we have our ground and then the motor control. So basically what we have is an electric motor that they're turning on and off with the control, and then the ground. Ground's probably permanent here, we can look. Yeah, the ground is a ground. And then the PCM sends out, probably 12 volts, I'm assuming, or some kind of duty cycle control on this control wire. And then we have our regular 3-wire potentiometer. That way there, it's a feedback circuit. It tells the PCM like, hey, I'm here, I'm there, lets it know where it's at. In some range, probably between 0.5 volt and 4.5 volts is my assumption. Okay, so that's a lot of guessing, but I'm assuming that's how that works. And then let me answer the phone. Stand by. And then let's look at the monitor condition. So it's monitored when the key is on, battery voltage is above 10.4 volts. And then to set the code, the PCM detects that the tuning valve position sensor input voltage is above the maximum acceptable value. So that's interesting. And then it gives you all the possible things that could possibly be wrong. And then it gives you the flow chart if you want to go down and do all your resistance checks and all the nonsense stuff. So anyhow, let's get after it. We've got a wire diagram. Let's find this little fella. We're going to zoom in on this. So we've got our wire colors, where they're at, and all that stuff. And I'll show you where it's at here on the vehicle. All right, and I think just one thing real quick, like a little bunny, prior to doing that, let's just pop into PCM, and then let's go to some data, because we should be able to see data on this, see some feedback. I don't know what's going on with the scan tool here. There we go. MFV maybe? No. Manifold, I don't know what the acronym they're going to use. Valve, no. I think maybe... I'll find it here. Is it flow? Nope. I guess I'll have to take a look here. I'll scroll through the list and I'll see if I can find it for us. Here we go. FCV, flow control valve. Okay, so we want FCV. Boom, here we go. So our flow control valve position currently is at 0.9. And it's showing its open position of being 4.1 and its closed position of being 1.5. So that's interesting if this is the actual feedback on it. Okay. Let's see, do we have control of this thing? see, did I miss it? Here we go, flow control valve. I don't hear anything. Well, we gotta click start. I think these things are kind of noisy, but I can't hear it. I can hear the auto shutdown relay kind of humming and then going away. So the command is being sent. So we're gonna go ahead and stop that. It's too bad we can't see some data here. I know on aftermarket scan tools you can. So there are some advantages and disadvantages to both tools, whether it be OEM, because I know with the Altel that if we do this test, I know in the past I've done it and you can see data. So it's kind of a darned if you do, darned if you don't type thing. So I'm gonna go back here for a second. And what do we say? FCV, flow control valve. And then let's go find this little guy and see if we can run some of our own tests and see if it's not getting the command or what in the heck's going on here. Now I could be wrong. This may not, it may not be new, but I did take a little peek down there. I see somebody's fiddled with this clamp. So, oh, and this clamp's already loose. So yeah, I might be right. Let's see here if we can't get the, I might just have to take this side off here. Let me get a pair of pliers here for us. Probably could have got a smaller pair of pliers, right, my guy? You ding dong. There's that. We'll set our little clamp to the side. Swing this baby out of the way. There we go. Let's make sure we're not doing any damage down here. We're not. Okay. And this tuning valve is right here. And it does look pretty shiny. It does have some dust on it, but it looks pretty new. I tell you what, let's, I guess we'll just get this whole thing out of the way here. Might make it a little easier, especially if we're doing some wire chasing or something. Not sure right offhand if they make these aftermarket, you know, if we just got a possibility of having a new bad one on there. But the customer did not disclose to me that they had been working on this. They just made the appointment for the money light. So I think what we'll do, oh, that's what's humming. Oh, so that's pretty interesting. Okay, I thought it was the auto shutdown relay over there humming away. Let's see what that does to our data. So we can see, let me get this turned around so I can see it. So we can see the position. Oops, not responding. What's going on here? Y-Tech, oh, I bumped the dang connector here. There we go. So we're at 5 volts, unplugged. We plug it in and it goes down to 0.9. So it's just reading the feedback, so that's interesting. Let's just do some circuit checks here. Now these things can be mechanically stuck. The intake manifold, the valve in there can actually be stuck itself. But let's just see what we have here electronically. Make sure it has the ability to function. Particularly on our Chrysler, we want to make sure our ground's good. So let's get us, we got a good power source right here. We've got a good ground source. Let's get us a Tesla 8 and get after it. Print this out of the diagram here for ease of use. We're going to clamp right onto a power source here first, because we just want to see if we have our ground, which according to our diagram is pin number 1, and it's supposed to be a black wire. I think it's the only black wire here, so let's find out, and it appears to be so. And we have a ground that can carry at least 700 millivolts. The light looks pretty bright, so that's good. What we want to do now is find the sensor signal, so that's yellow and dark blue. Let me get this back up on your screen for you. Okay, let's see here. We want to focus on this one here. So our 5 volts, that's our signal wire. And we are going to hook back to a ground. Get this clamped on here for you. There's that, we're hooked onto a ground. And our signal wire is going to be yellow with dark blue, it says. It should only be one of those. And that, I think, is the second one in. And that should pull it down to ground. It does it, and it does. It pulls it to ground, and then it goes back to 5 volts. So that tells us our signal wire is intact. Here, I'll hold the test light on it. So that's good. what we would need to do now is we would have to get a voltmeter and check the 5 volts supply to it, and also the sensor ground. We can do that. But prior to doing that, let's hop back into our actuator test here. Let me go get a different test light. We'll get something here that draws a little bit more current. We're going to go to flow control. We're going to select toggle, and then we're going to hit start. And it should be toggling currently. So we want to go to ground, which was our black wire. So we're going to probe into the black wire, which is the ground. And then we want to find the control, which is supposed to be brown and purple, which I think is the other one right here. And this should be toggling on and off. And this draws a couple amps. This is like a 2.5 amp test light. So we see it has the ability to function. All right, and then let me just hit stop over here on the scan tool for us. So we stop that. That turns off. So that's good. So far, so good. We're going to we'll back right back out of here. We'll go back to our data. And then we'll bring everything back up on the screen, FCV. Okay, now what we'll do, she's a humming. I wonder, just for poop and laughter. Just give her. Temporarily quit whining there. Oh. 0.74. Yeah, it seems to be kind of hanging around there. So let's, I'll stop this. I'll go get a meter. We'll check our 5 volts. We'll check our ground, and then we might have to pull it off to see if it's physically stuck. So pull up a graphing meter here. We'll go to volts DC. This is nothing fancy. I like using this because it has a big screen and I got old eyes. So we're going to go to, we're going to just get a couple T-pins here. We're going to do a ground. We'll get another T-pin here. And then we'll go to the 5 volt supply. So the sensor ground is dark blue with light blue. And then what do we got for the 5 volt supply is yellow pink. So dark blue, light blue is this one right here. And then yellow pink is this little fella right here. And we have 4.97 volts. And the only thing I want to do is just to make sure that we maintain that with it plugged in. You know, load the circuit here a little bit, or let it test it with it live. So we're gonna take and back probe it from the back side, just to be 100% certain here. So I want to make sure I get a good back probe on it. Get beside the pin here. Sometimes that can be a little tricky. You can really screw up the weather pack too if you're doing the old poke and hope, so just be a little respectful of the connector. So that is our 5 volt supply. I'm going to elect to just use this ground. Click on there. Oops. So we've maintained our 5 volt supply with it plugged in, and then I'm going to take and just unplug it. And I probably could have done them both, but I didn't want them to touch together, kind of a tight spot. And then I'm going to check the ground here. So that's plugged in. Clip it on the ground. Oops. And then that should stay around 0 volts, and it is. And then we're just going to flick it over to battery power in order, you know, of course it's going to be backwards, but minus 12.23. So we have a good ground. We have a good 5 volt reference, and the signal wire functions. It goes from 0 to 5 volts. We've seen it on the scan tool. We're able to pull it down. It also goes up to 5 on its own, and it has the ability to function as far as the motor, because that can take a couple amps of current, and it toggles it on and off nice and bright. However, it's not doing what it's supposed to do. So we're going to take and pull that off, see if it's physically stuck. And if it's not, then, well, guess what? Guess what, lady? You need a new motor. So we'll turn that off. Let's see, because we're just pretty much down to the point of does it need a manifold or does it just need the tuning valve or the control valve or whatever it is Chrysler calls it, the little control valve. There we are. There's that. Like I said, that one there is different. Whether it's supposed to be or not, who knows. Take this thing off. There's that. So it has a piece here that goes into the intake. And it must engage. Let me get a little flathead screwdriver to see if we can't feel that thing. I'm going to take and pull that back out. I want to look in here in the intake. I don't know if this is broke or if this is supposed to come out. Seems kind of odd. It's been a hot minute since I've done one of these. I don't ever remember a secondary piece here just pulling out. Probably could look at service data, but right here, that thing was all loosey-goosey in there. That's interesting. Let me look in there with the mirror. And there is the female half of the slot in there that I can see. So that's good. I'm gonna take and lubricate this O-ring just so it gets a little smoother operation so I can tell, you know, is it binding? Is this thing binding? What the heck's the deal? I threw a little bit of KY for cars on there, silicone grease. Let's see if I can't guide myself in. I'm gonna stick a flat blade screwdriver in it. Doesn't feel like there's a lot of movement there, my guy. I don't know how much it's supposed to move right offhand. Well, it doesn't really feel like it's moving a whole lot there, fella. Let's go like this. Let's plug this thing in. Alright, she's plugged back in. Let's see if this has the ability to move now. So it does appear to be doing its thing. I don't know how far it's supposed to rotate. That's about as far as we could rotate it in there. I'm just holding back some resistance on it because I'm kind of curious what it feels like. The other thing while it's toggling, let's probe that signal wire just so we have some live data and see is it indeed, you know, just stuck at 5 volts because maybe the intake only moves that far, just this part is junk. Unenhanced. So we're going to go to a ground, put that back on ground. We will get us a probe and the signal wire, if you remember correctly, was yellow and dark blue. Then we're going to get it ground again because Snap-on makes their leads like super convenient. Not really. They probably have some of the worst leads on the market. I do have some nice ones from AES Wave. Who makes them for some of the Snap-on tools, which those are great. So that's still toggling. What was it, yellow and blue I told you? So we're gonna back probe it. Hopefully we're in the right hole, baby. We're gonna go down to graph, oops, nope, 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 there. Graphing. Volts DC, I'm gonna show you here in a minute. Bear with me, baby. So we're not in the correct wire. I thought it was yellow and blue. There we go. Interesting. It's going from 0 to 5 volts. Let me get a good probe on that because this should be our ground wire. Oh gosh, you guys can't see, can you? Let me just double check something here. This is our 5 volt steady, so yes, and this is our signal wire. Get a good probe on it. It's probably because we're allowing it to make a full sweep. Let me get this where you guys can see it. Hopefully you guys can see it. Okay, you can anyways, right? Get that set up there. So it's going from 0 to 5. I'm wondering, we should be able to It's got a pretty fair amount of torque on it here. Okay, let me take and shut that off because what I'm doing is nonsense. I'm going to stop it from toggling, and it did rest, or it is resting in the 5-volt position. I'm just curious. Oops, meter fell off here. Sometimes service data won't disclose how it regulates where it starts and stops, so we can go through the whole spectrum of the potentiometer there. It does appear to have a little glitch in it right there. As you guys can see, once I get to a certain range, it does glitch out. So that's pretty interesting. It does have a glitchy spot in it. Right there about, it's in the 1-volt range, I think it was. I think we're coming up on it somewhere here. Yeah, right about there. So it's in about that 1-volt range. I'm holding it nice and still, but you can see as we sweep that potentiometer across it, it definitely has a spot that's crappy. So I'm just taking and sweeping it up and down. So that's its max range, 4.6. We run it down on its low end, and it's got some weird stuff going on there. So this thing has definitely seen better days. I'm still questioning whether or not the intake is binding there. This obviously has a very short throw. I hear it thunking in there, but I mean, besides the slop of my screwdriver, I mean, I'm barely turning this thing. Yeah, I mean, that sucker, I mean, it is just barely rotating. I'm not super pleased with that, to be honest with you. I think, because I mean, there's a little bit of slop and everything, and I think by the time we take slop out of it, we're not really turning anything here. I'm gonna see if we can't get a longer screwdriver in there into that female half that's in there. I know you guys probably can't see it, but I want to see how much it's actually physically turning that. Because I do know, I think the earlier models of these, or perhaps even some of these models had, I don't think it was a recall, maybe it was a recall, or maybe an extended warranty on the actual intake manifold itself. Let's see if I can reach in there with something. So that thing is rotating, like I said, taking the slop out of my screwdriver and stuff, maybe not even 1/8 of a turn. I mean, I can hear it kind of thunking that way and that way. I mean, it maybe only rotates total like a 1/16 of a turn out of, 360 degrees. So it barely rotates. I would have to compare it to a brand new one, is the only thing that I could say would tell us one way or another. And that's the same thing I get out here. So it is fully engaged, but it certainly just barely rotates. And the only way to know for sure, I can look in service data, it may or may not disclose how much they actually rotate. We could compare it to the entire sweep of the motor to see how much that rotates to get a full value from open to closed, or get a new one if I didn't already say that, and actually compare it to see, and then check the new one obviously before you pull the old one off to see how much that's supposed to rotate. But it's quite clear to me that the potentiometer in this has a glitchy spot down near the 1-volt to 1.5-volt scale. So definitely needs a motor. Intake is still pending, in my opinion. So I believe, in my opinion, I'm going to err on the side of caution, let me turn this off. I'm going to tell my customer I would, recommend to them we get an intake manifold. Obviously, we need a new control valve, and then I'd get an intake here. And this car's got a lot of miles on it. I wouldn't be surprised if once we compare it to the new one, we find out that we need to replace it. So I think I am going to quote them on the motor and then the intake manifold also, because it's easier and better for the customer to take money off the bill than it is to add money to the bill. So that's how I'm going to handle that one. Say, hey, here's where we're at and here's what I'm thinking. But I'd be willing to bet we're going to need the intake manifold just based on what I feel. And then I also, just off camera, was checking the sweep on this from its 0.5 volt range, or its 1 volt range, up to the 4.5 volt range. And it's a much bigger sweep than actually what I'm turning that valve inside the intake. So I wouldn't be surprised if that's what we're going to find. So I'm going to put the screws back in it, put the tube back on it. Let's see if we get the job. If we do, we're a little ways out on appointments anyways as far as fixing it. So we will see. And this guy honestly does quite a bit of his own work. I've done some Diags for him in the past, and he's done the repairs. So I don't know if we're going to get this one 100%, but if we do, you'll be the first to know. So now that we have that sorted, we have to look at the PO 456, I think it was. Let me see here. Let me get a printout here for the customer. Yeah, PO 456, so it's a small evap leak. Got a little experience with these, so we're just going to cut to the chase. ESIM switches go bad. Typically, we'll throw large evap leak code. These cars have a fatal design flaw. Not fatal like you're going to die, but fatal in the sense that it's put together wrong. And we're going to see if I'm right on this one, which I think I am. Purge valve hides way down here. When they put these junkers together at the factory, they run the transmission shift cable really close to what they call the purge valve harness. So that's the vacuum hoses that come off the purge valve, and they touch and they rub like this. And eventually it rubs a hole in it. So you see that a lot in these Sebrings. Let's go have a little look. I may be wrong. I may be right. Let's see, are these long ones? Yeah, she's long. Let's go have a little gander here. Now I'm using my left hand, and I'm going to try to do it through the viewfinder. So there, I'm going to push this as the vacuum supply hose, and hence. And we're going to be looking at that, not this hose that I'm wiggling, but the one right below it. You see where the two cables are kind of kissing each other down there? Like you kiss your sister, and you see how it's going to have a rub hole right through it. You see how that's kind of curved right around to fit over that hose? Well, it ain't supposed to be like that, fella. And I bet you dollars to donuts on enhance that that she got a hole right in it. I almost guarantee it. Let me go get a mirror.
What's going on?
I need you. We need you. The people need you.
Okay.
Can you help us?
I'm coming.
Shalom. This way, Mrs. O. Walk this way, you ready? There you go. Whoops. Too much hips. Let's see here. I need you, if you wouldn't mind, get us a mirror.
Mirror?
Yeah, mirror. Black handle one would be good. All right, Mrs. O. What we're doing, showing the people how we just diagnosed this one with experience. I think you need to be camera lady. Let's switch. Are you ready, camera girl? Mm-hmm. Let me get in here first. You stay back for a minute, because I don't even know if we can show the people. I don't want to put the car in the lift, you see. Just a minute. Maybe I can.
You're avoiding putting the car in the lift by holding the little mirror?
Yeah, it's what we do, okay? I'm a mechanic. We'll take every shortcut we can to not save time. Gosh dang it. I tell you what, let me see if I can just stick my pick in the hole. Oh, boom, there we go. Proof's in the pudding. I'm in the hole, baby.
What are we seeing?
Just a minute. You might have to enhance. enhance. That's the top button. But you have to say that when you push it. When you push that to the right, say enhance, enhance. Okay.
Too much.
Then you say unenhance. Let me get my hand down here. Son of a boy, she's tight. I can't get in. Can you see where the end of my pick is by any chance? See it down here? Oh, boy, here. Unenhance. Unenhance.
I'm looking.
See, I'm wiggling it. You feel me?
No. I mean, I can't see it. I mean, I see
In
it.
the viewfinder.
Oh, there's a hole
in the viewfinder, baby.
There's a hole in the
Tube,
hose.
right?
Yeah.
Okay. That they just need a
Can they
confirmation.
see it? I don't know. Can they?
No, that's all good. It's good. Okay. Just all right. Back out. Unenhance. I don't know about your videography. You're probably worse than me, and I'm pretty terrible. But anyhow, I just wanted to show the people that we don't even need the Avoca smoker. That experience-based diagnostics led me to where we're at, Miss Though. Until I got it. That's it. Show's over. Cut. I won't tell him. Thanks, Mrs. Though. I think you did a fine job. You're just gonna have to trust me. The transmission shift cable rubs a hole through that hose. I remember the first one of these I saw. I thought perhaps somebody put a tranny in it, something like that, and kind of had the wires crossed. But I've seen it enough now to know. Like it's just a thing. When we replace them, sometimes we'll take and stick a piece of like fuel line over it to keep it from rubbing through, or you can kind of zip tie the cable back out of the way. But you know, let's think about it. It's an '08. It's going to be the first time it happened. It's got 166,000 miles on it. It's not going to live to see a second one, trust me. And then also when you go to order that from Chrysler, they call it an Evap harness. I don't know why. But you get both vacuum hoses on, so you get the vacuum hose that goes to the intake manifold, and then you get the vacuum hose that clicks onto the hard pipe that goes back to the vapor canister. And you get the purge valve, and it's only like a couple more dollars than buying the whole purge valve itself. So, free tip for you, call, get it. If you drive one of these cars, go out there and wrap some rubber hose around it, or pull the shift cable out of the way, whatnot. Anyhow. I got 2 o'clock coming and we gotta go. Comment section, questions, concerns, Insta, Facebook, you know the deal. And just remember viewers, if I can do it, you can do it. Thanks for watching.